There we go. Hello, everybody. Welcome aboard. Let's see here, guys. So if we look at our warm-up here, we need in quadrant one a plane that goes 15 on the x-axis. That's 15 left and right, and 40 on the y-axis. That's 40 up and down. So it should look something like what I'm going to draw while we do our essential question stuff. Guys, it is the 75th day of school. Did you guys know that not counting the infinite classes of prisms and antiprisms, there are exactly 75 possible uniform polyhedra? What a uniform polyhedra is a 3D object whose faces are all regular polygons, like squares, equilateral triangles. They're polygons where all the sides and angles are the same. And in fact, if you look at this poster over here that I have, it's a black poster with all those shapes on it. It actually has all 75 that not that we know of that are possible. Here guys, let's stop doing the helicopter thing. It is a big distraction for me. It's the International Day of the Monkey. Yay! Yay! Oh, that was a muted response, but okay. Let's see here. What is our first essential question? And I would love to get that one from Sawyer. What is the slope of a line? What is the slope of a line? Very good. And then what is our second essential question? And I would love to get that from Ruth. Yeah. So the questions are, what is the slope of a line? And then how do the slope and y-intercept of a line? Of a line connect an equation to its graph. Perfect. So what the acronym stands for, guys, ASAP, really does stand for as soon as possible. As soon as possible. It's exactly what it stands for. And then at the fair, that is indeed a pig. That is a pig, and I understand at fairs. I've never seen one, but I've always seen it advertised where they have like pig races. Do you know what I'm talking about? Like they always say that there's going to be pig races, but I never seem to be there when it happens, and sometimes I wonder if it's a big trick and they don't actually happen. Anyway, underneath all this, and kind of near your coordinate plane, got a pencil? Today we're on the search for slope. And hopefully we've got a coordinate plane. I'll at least get it started. Again, those of you at home, it needs to go 15 this way and 40 this way. And you'll see why right now. Three more graphs. Three more graphs. So thirsty. Catherine, Louise, and Carly are lost in the Mojave Desert and they are rationing their water in different ways. So we're going to start with Catherine. Catherine has 30 ounces of water left and is drinking 2 ounces every hour. Does that make sense? Every hour, her watch goes beep beep, and she's like, okay, I can drink 2 more ounces. And then she drinks it, and then she puts it away. And does that make sense so that it'll last as long as possible? Here's what I want you to do, guys. I want you to use that information to make a table, an equation, and a graph representing how much water Catherine has left if she's got 30 ounces and every hour she drinks 2 more ounces. So make a table, use the table to make an equation, and then use the table to make a graph. Talk to each other and let's see how it goes. Teach, teach. Some of you guys already got it. That's great. Hi, guys. Come on in. Which number? 23. Grab 36 for now, and we'll figure it out later. The whole thing is messed up, and I think we need to completely realign everything. Let's see here. Ah, there we go. Oh, Elisa can help you with that. She has the rule book. All right. Eleven, 12, 13, 14, 15. Okay, and then here we're going to 1, 2, 3, 4, 5, 7, 8, 9, 10, 15, 20, 25. Hmm. 10, 15, 20, 25, 30, 35. Yes, please. Yep, that's right. That's what your warm-up's for. Very good. Oh, have you got it all filled out? Okay. Whoop. So you should have something like this, and then we're going to keep track of Catherine. Just a second. Yep. Better count that by twos. Getting a little crowded. Okay. Catherine, what's your favorite color? Purple. Okay. Let's get to it, guys. Can I get you in 5, 4, 3, 2, 1? Let's see if I can get a little bit of help out here. Charlie, on this guy, Catherine starts off at 0 hours, right? And I'm going to use X and Y. I heard some people use H and Z, H and O. Whatever you want to use is great, but I'm going to use X and Y because it's on my XY coordinate plane just to kind of get my head in that gear. So after 0 hours, how many ounces does Catherine have left? Now, that's how much she's had to drink. She had 30. That's right. She had 30. She had 30 ounces. After 1 hour, what does she have left? 28. 2 hours, 26. 3 hours, 24. 4 hours, 22. 5 hours, she's got 20 ounces left. So she's rationing off her water. Like that. I don't know if I think I've heard that before, that if you're in the desert, you shouldn't ration your water. Is that true? Do you guys know? I think I've heard that you're supposed to just like chug everything you have. Because it doesn't matter if you drink it now or later, but it might evaporate. Or someone might steal it. Yeah, go ahead, Josh. Uh-huh. So, Josh asks a great question, guys. If I can get your voices off, maybe we could all hear it. Because Josh asks, why is it subtracting? And here's why, is because we're not keeping track of how much water that Catherine's had to drink. we're keeping track of how much water Catherine has left. And since she's drinking 2 ounces every hour, she starts with 30. If she drinks 2 ounces, she's got 2 less ounces now. And then an hour later, she's got 2 less ounces. So it's like we're subtracting 2 ounces away every time an hour passes. And that's why it's subtracting and going down. Let's take a look at what it asks. So, it doesn't ask anything. So when I told you guys to keep track of this, I said keep track of how much water Catherine has left. If I'd said keep track of how much water Catherine's had to drink, then you would do 0, 0, 1, 2, 2, 4, and so on and so forth. And then that would be a proportion, whereas this one's just linear. Okay. You know what's interesting? I keep hearing people come up with the equations before they come up with the table, which I actually really like. Luna, what's the equation that could represent this? I'm glad we're talking. I heard someone say it. Does someone have that equation for me? Yes, B. Excellent. So I'm going to say mine is y equals 30 minus 2x. If you did z equals 30 minus 2h, totally fine. Totally fine. But I'm going to call it y equals 30 minus 2x. Now let's go ahead and fill in those places. So you got 0 and 30, so we're going to put a dot right here. 1 and 28. And then 2 and 26. 3 and 24. Oops, I messed up somewhere, didn't I? Hang on, that's 2. There we go. Now those are all the points I have for my table. How many of you feel like you could actually extend this a little bit past where you have on your table? Like, I don't want to put 618, but I know that it goes through 618, and so I can put that on there. And the truth is, guys, I could actually put down all the points on this line because it follows a pattern. Thank you. Now, should that be a dashed line or a solid line? That should be a what? Everyone, that should be a... Ooh, I heard solid and dashed. Why don't you guys talk it out? Should that be solid or dashed, and why? Teach! Go ahead and pop that down there. No helicopters for me. Um, yes, please. Yes, please. That's fifth. Using fifth. Okay. Can I get you back up here in 5, 4, 3, 2, 1? After a talk, guys, do you think it should be solid or dashed? I think it should be... Ooh. Do you know what? I'm going to say that it should be dashed. Can someone explain? I know that you can drink half an ounce of water, and I understand that. In fact, there's going to be people who do that. But can someone explain to me why that maybe that should be dashed? Why should that one be dashed? Yeah, Josh. Yeah, if you look at what's happening, Catherine has 30 ounces left, and she drinks 2 ounces every hour. So her watch beeps, and she drinks 2 ounces, and then she puts her water away. So we're going to use a dashed line for this one. We're going to use a dashed line for this one. Because if it was solid, what you're saying is that Catherine's got like a camelback and is just slowly drinking 2 ounces every hour, which feels like that would be really hard to control. Right? All right. So let's use a little dashed line. Just like that. You guys doing okay so far? You guys got Catherine? Should we do another person? Let's see here. Who else is here in this desert? That's right. Luis is in the desert. Let's see what he's up to. Now, Luis has 40 ounces, and he's drinking 8 ounces every 3 hours. He's drinking 8 ounces every 3 hours. So every hour, he doesn't like... Every hour, Catherine takes a sip. Luis waits much longer, but he takes more water. Every 3 hours, he drinks 8 ounces. Can you guys come up with a table, an equation, and a graph to represent that? I'm going to give you a minute to talk about it, and then I'm going to start his table to give you guys kind of a hint, okay? Talk it out and teach. I wonder what Luis's favorite color is. Oh, we already used purple. Well, oh no, keep it on there. Keep them both. We'll just use the same. Use the same coordinate plane. That's why we made the coordinate plane the way we did. Use the same one. Use the same one. Great question. We'll do red. It looks very different than purple. Okay. Here's my recommendation, guys. Maybe that will help you make a table for Luis. If you keep the x values in multiples of 3, so 0 hours, 3 hours, 6 hours, 9 hours, 12 hours, 15 hours, because that's when it changes, right? And every 3 hours, he takes 8 ounces of water. So yeah, he doesn't drink as often as Catherine, but he gets to drink more. No, don't erase. Oh, you don't have to erase anything. Oh, you made another one? Okay. Well, let's just. I'll tell you what. I like this one the best. So put both of those on here. He's drinking 8 ounces every 3 hours. 8 ounces every 3 hours. Sorry, should have kept that up there. Yep, he starts with 40 ounces, and he's drinking 8 ounces every 3 hours. I'll pull that back up now that you guys have got that little hint there. So at 0 hours, how much water does Luis have? 40. So it's going to start at 40. 0 and 40. Mm-hmm. Does anybody know the answer if that's true or not? If you're supposed to drink all the water you have, or if you're supposed to ration it? You're supposed to drink it? Yeah. People get rescued from the desert, I think. It's a great movie. Which I think that's now they're mentioning it, I think that's Tom Hanks, but I don't know what movie that's from. Right? That's Tom Hanks, isn't it? Hang on, let me turn off the light. Is that Tom Hanks on there? It looks like Tom Hanks. Yeah. Oh no! I thought the terminal was cute. Sure. Yes, right. Well, what'd you do? Oh, it's my seventh graders trying to cheat. Not really. What's funny is that if they do that, it looks like you're cheating, but really you're just risking getting it wrong. So they were like, hey, I can do this with my calculator. And I was like, you can if you're careful. So I recommend you do it by hand. How do I do it with my calculator? Why would I take the time to show you that? Like, we got other things to attend to. Okay, come on up in 5, 4, 3, 2, 1. Let's see what we got out there. Let's see if I can get a little help from. That's going to come from. There we go. Catherine, how much water does Luis have at 0 hours? He's got all 40 of his ounces. 3 hours later, what does he have? And then? Uh-huh. Indeed. Uh-oh. Oh, no. Yeah, exactly so. So we can actually graph the entirety of Luis's situation pretty easily. So let's do it. I'm going to do it in red. And he's going to start at 40. And then 3 hours later, 1, 2. Well, so there's 3 hours and then 30, 32. And then 6 hours and 24. 9 hours and 16. And man, I don't know if you guys have noticed this, but look at this. I'm going to do something here, and I'm going to be thinking, I really want to say it out loud, but I'm going to do something to get the rest of these points down, and I want to see if you can see what it is. Let me make the dot nice and big so you can kind of see what I'm thinking. Because I don't like having to scroll down all this way. So here's what I'm going to do. How many of us think they saw what I did right there? How many of us think they saw what I was doing with those little ticks? Awesome. And then we're going to connect it with a dashed line. And, oh, I don't like that. That's better. Okay, so there's Luis. There's Luis and Catherine when they're drinking their water. And there's one more person here. Who is it? Yeah, Carly. Oh, wait a minute. We forgot something. We forgot something very important on Luis here. What did we forget? We forgot the equation. We forgot the equation. How many of us also don't have the equation on our paper right this second? Yeah, because the equation for this is a little bit tricky. Put your pencils down for a second. Here's how we're going to find the equation. I gave you this hint to get Luis's table done by counting by 3 hours because that's what Luis is counting by. But what if I'd actually insisted that you count by ones? 0, 1, 2, 3, 4, 5, 6. When I say teach, I want you to say, okay, will you guys talk to each other? We know it's 0 and 40. We know it's 3 and 32. We know it's 6 and 24. But how would I fill in the ones and the twos? What can I do to fill, like, let's say that Luis is actually, he's drinking 8 ounces every 3 hours, but he's actually drinking every hour, just like Catherine is. How much should he drink every hour? Talk to each other and let's see how that goes. Teach! I see you guys pulling out your calculators. That's good. Okay. Can I get you back up here in 5, 4, 3, 2, 1? Josh, I saw you pull out your calculator. What did you put in there? 8 divided by 3. If he's drinking 8 ounces every 3 hours, then 8 divided by 3 will tell you how many ounces he's drinking every hour. And what was that number? 2.6 repeating, which is to say, unless you've already got one, got a pencil? The equation is the really annoying looking y equals 40 minus 2.6 repeating x. How many of us that equation just makes them want to throw up a little? Like they threw up in their mouths just a little bit right now. Yeah, absolutely. That's I don't want to look at that equation. So we have to go back to what Josh did to get that number. What did Josh do? He did what divided by what? He did 8 divided by 3 to get a unit rate. So we're going to not do this, and we're going to say y equals 40 minus 8 thirds x. Now, I know you might like that even less than the repeating decimal. Probably not. I don't know. I feel like in the grand scheme of things, everyone likes decimals unless they're repeating, in which case they like fractions. Does that sound about right? Like, maybe? Anyway, and here's why I'm doing this, guys, is because in Catherine's equation, 30 is hidden inside of this line, and so is negative 2. In Luis's equation, 40 is hidden inside of his line. And so is negative 8/3. How many of us see the 30 in Catherine's equation? How many of us see the 30 in Catherine's equation? How many of us see the 40 in Luis's? How many of us see the 2, the negative 2 in Catherine's? How many of us see the negative 8/3 in Luis's? Maybe some of us are starting to get an idea. Let's see what we got with Carly. Carly's maybe be who we need to help us out with this last one. Here we go. Finally, Carly only has 6 ounces and is drinking 2 ounces every 5 hours. She's really trying to ration her water off because she does not have very much. So she's got 6 ounces and is drinking 2 ounces every 5 hours. Can you make a table, an equation, and a graph to represent that? Table, an equation, and a graph on that same coordinate plane? Give it a try, and here we go. Ooh, good luck, Carly. Teach! Okay. 6 ounces is not very much. That is not very much water. Yeah, I think Carly might be in trouble here. So then what would the equation be? And then what would it look like on a graph? Awesome. Thank you so much. Let's see. So this is... Oh, here, let me grab some Posties. Thanks, Elisa. Okay, let's see here. So Carly's got 6 ounces and she's drinking 2 every 5 hours. Does anyone know what Carly's favorite color is? It's purple? Pink, maybe? Is it green? Maybe it's green. Okay, let me go ahead and I'm going to set up Carly over here. You know, green is very different, so we're gonna take a chance on green. And there's X and Y. And I'm gonna count 0. And since he's taking 2 ounces every 5 hours, 5, 10, 15. Now at the beginning, she's got 6 ounces. How much does she have after 5 hours? After having 2 ounces, she's got how much, everybody? 4. How much after that? 2. And then, uh-oh. So we're gonna go 0, 6. Now watch me. Watch what I do here. Because I'm sick of scrolling down so much. I'm going to do this. Watch this. 0 and 6. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5. 1, 2. How many of us think they saw what I was doing there with the 5 and the 2? Did you guys see that? Did you guys see that? Maybe? Here's the trick, guys. Well, maybe we can talk here. And then we're going to go ahead and highlight here. Let's get Carly's equation. Let's get Carly's equation. So to get Carly's equation, we're going to do the same thing Josh did, where if you were counting that every hour, like let's say every hour, all 3 of them take a drink. They're keeping it that way. But it just so happens that every 5 hours, Carly drinks 2 ounces. So my question is, what would I do with 5 and 2 to find out how many ounces she's drinking every hour? Luna, go ahead. Yeah, should I do 5 divided by 2 or 2 divided by 5? So that would be 5 hours divided by 2 ounces. That would be 2.5 hours per ounce, so we got to flip that. So we're going to do 6 ounces minus 2/5 times the number of hours. And that's this line right here. Okay, here's what I want to talk about. This 6 is hidden in Carly's line, and this negative 2/5 is also hidden in Carly's line. Luis's minus 3/8 is hiding in that line, and so is the 40. And finally, Catherine's 30 is hiding in her line, and the minus 2x is hiding in that line. When I say teach, I want you to say, okay, can you find those connections? How does the number in front of my x, like the 30, the 40, and the 6, how do those show up on my graph? And then, a little bit trickier, how does the number that is next to my x show up in there? The minus 2x, the minus 8/3 x, the minus 2/5 x. How many of us, by raise of hand, think we see something? Ah, okay. Talk it out. Where's the 30, 40, and the 6? Where's the negative 2, the negative 8/3, and the negative 2/5? Give it a try, and here we go. Now I'm thirsty. Teach. Well, for Carly, that was y equals 6 minus 2/5 x. They're doing that slinky thing outside, and it makes it sound like there's a bunch of snakes out there. Wind, yeah. That would be bad if you were like, sure, it's windy outside, and you open your door and it's a bunch of snakes, and you're like, that's not what I wanted. Not a really good way to start a Wednesday, but okay. All righty, everybody. Can I get you in 5, 4, 3, 2, 1? Let's talk about this 30, 40, and 6. Sawyer, where do the 30, the 40, and the 6 show up in those? Or should I say, Sawyer, where do the 30, the 40, and the 6 show up in those lines there? Exactly. Exactly. Very good. Guys, those numbers, the 30, the 40, and the 5, those represent what's called a y-intercept. It's where your line touches the y-axis. It's where your line touches the y-axis. Callie's line touched the y-axis at 6. Catherine's line touched the y-axis at 30. And Luis's line touched the y-axis at 40. How many of us figured that out? We got that okay. You guys all right? Good. Now, did anybody see where the minus 2, the minus 2/5, and the minus 8/3 came in? Well, I'm really glad we're talking. Put your pencils down for a second. Let me show you where they are. Let's look at Luis's here. Watch this. This is sort of what I was doing here, and let's see if you can catch it if I do it like this. Guys, if I know that I'm starting at 40 because the 40 tells me where to start there, and I'm looking at 8/3, here's what I'm going to do. Every 3 hours, 1, 2, 3, how much does Luis's water go down? 8, right? 1, 2, 3, 4, 5, 6, 7, 8. 3 hours later, 1, 2, 3, how much does his water go down? Another 8. 1, 2, 3, 4, 5, 6, 7, 8. 3 hours later, 1, 2, 3, how much does Luis's water go down? 1, 2, 3, 4, 5, 6, 7, 8. It tells me where to go. So does Catherine's. Catherine's was negative 2/5. So if I go over 2, or over 5, 1, 2, 3, 4, 5, how much should I go down? 2. If I go over another 5, 1, 2, 3, 4, 5, how much should I go down? 1, 2. Then I should go 1, 2, 3, 4, 5, and then down 1, 2. It's a way of counting. Catherine's is kind of weird because I go down 2, but how much did I go over to go down 2? Like if I go down 2, how much do I go over? 1, because each 2 boxes counts as 1. That's how we set it up down here. See how each 2 boxes counts as 1? So that's because secretly her equation is 30 minus 2 over 1 x. It's okay, guys. What we're going to do is we're going to sleep on this, and tomorrow we're going to talk more about it, but we're not quite done. Got a pencil? Okay, let's see here. So what I want to do is I want to write down something really quick. The y-intercept of a line, I said got a pencil, didn't I? The y-intercept of a line tells us where to start. It tells us where to start on the y-axis. And that other part is called the slope. The slope of a line tells us where to go. And that's what we're going to talk about tomorrow. Tomorrow we're actually really going to dive into this and practice these guys. You guys did win the scoreboard game, and I think you guys do deserve a point, guys. Thank you very much, everybody. You can put your calculators away. The last person to put their calculators away and return to their seats, please bring me back my rulers. And we'll call